Okay, so I've actually grabbed two problems. So just make sure to leave enough space for two problems here. They're two kind of smaller problems, but two different types of ways that we can have a Venn diagram situation. So here's one where it doesn't even tell you that you need to do a Venn diagram. It just wants you to find probabilities. And here's the thought process of maybe how a Venn diagram could help. So it says in a class of 30 IB students, 20 students study mathematics, and 12 study physics, and 8 study both. So this idea of there being like some sort of overlap, it's not like a sequence of events. That's when you should start thinking like, oh, okay, maybe I should be creating a Venn diagram here. So I'm going to first start it off by, so let's call this example 10. By drawing my circles, having that overlap, I'm going to have M for mathematics and P for physics, and then I'm going to make sure to represent U. Remember, it tells you that 30 is the total amount of students. So this is all out of 30 students. It says 20 study mathematics, so there's going to be 20 in this circle right here. 12 study physics, and 8 study both. Which one of these is the most helpful information? Which piece of information do you need to use first in your Venn diagram? What you need to use first is the fact that 8 study both. The fact that you know that 8 study both, that means that you can put 8 in here and it unlocks the rest of the information, right? So if you know that 8 are here in your total of 20 students that are in this mathematics bubble, 8 of them are also in physics, which means that then you have a remainder of 20 minus 8, 12 students who are just taking math and not physics. Versus your physics, where it says 12 are taking physics. So this whole circle right here represents 12 students. 8 of them are also taking math, which means 12 minus 8. There's 4 students who are only taking physics. Since this is out of 30 students, we need to make sure that all of these numbers add up to 30, which they don't. 12 plus 8 is 20, plus 4 is 24. We have 30 minus 24, 6 students left who take neither math SL or physics. Okay, so you've created this Venn diagram, which makes it easier visually to see the answer to this question that we're being asked. Find the probability that a randomly selected student does not study both of these subjects. So that's the probability of, we have the probability of them both, and we don't want it, right? So the people who study both are 8 people. So the people who don't study both would be the 12 and the 4 and the 6. So adding those all up, I get 20 out of the total of 30. So 20 out of 30, 2 over 3, or 0.667. Okay, our next question is here. So we could also be given a probability situation where we're just given these like, okay, P of this and P of that, and this is what this is, and find P of B. We're not given any contextual information at all. We're just given like this information that we have to work with. This is always a great way to, or a great hint that we should be using a Venn diagram in this situation. So I'm going to first set up A and B. And then U on the outside. We know that the probability of A and B, so this is like all of the things together, are 0.9, which means that all of this is, and all of this, so everything that's inside of this bubble situation is 0.9, which means that anything outside of that bubble situation has to add up to the rest to get us to 0.1, or, oh, sorry, to get us to 1. The answer is 0.1, right? So we have 0.1 that are not inside of here because I know that the A union B plus something has to add to 1 because A union B is all of the things that are inside of all of these circles, right? and this whole situation must add up to 1. If this is 0.9, then everything that's outside of that situation must be 0.1. So that is my first piece of information. I don't even know what the rest of the problem says. I don't even know what probability I'm supposed to be finding right now. All I know is that first piece of information, visually looking at it, I said, oh, well, that's all of this. Well, if I know that all of this is 0.9, then I know that what's outside of it must be 0.1. Okay. It then says that the probability of A is 0.5. That's helpful for a later date, but right now I don't have anything to do with that. I don't have anything that I can do with that because I don't know what's going on in the middle here. And then it says A intersection B is 0.4. So that's the overlap. It's what they share, right? It's that bridge that connects them. So then if that is 0.4, which I can do stuff with, that's pretty helpful information. Now I can start going in here and start filling in the puzzle pieces. I was told that the whole bubble of A is 0.5. Well, if 0.4 is in here, that means that the remainder out here must be 0.1. And then we just have one missing piece, which is what's the probability of B and not A? Well, I would do 0.1 plus 0.1 plus 0.4 is 0.6, which means that my remainder, in order to get me to 1, right? 1 minus 0.1 minus 0.1 minus 0.4 must be 0.4. So 0.4 is in this guy. Sorry, guys, I'm buzzing. So then the probability of just B is 0.4 and 0.4, right? That whole guy right there, we have to add those two together, and it's just 0.8. And there you go. This visual aspect of bringing it all together is really important. And so if you don't know what to do and it's not a sequential amount of events, a Venn diagram is probably what's going to happen. And then from there, you need to start figuring out the puzzle pieces of what's going to help unlock the rest of this information. And then how do all of these relate to each other? We'll practice it some more. Hopefully you'll feel confident on this before we take your test.